In this lecture, we'll see the working of D-gated NAND latch. With positive level, we can simply also call it as latch, D-latch. Okay, D-latch always means gated latch. There is no non-gated latch in D. Okay, this is the logic diagram. We can get to D-latch logic diagram from SR latch only. Suppose take SR. So in the SR, this will be S, this will be R. Just interconnect that SR and make it as D. Okay, then SR gated latch will become D gated latch. But here, if I are using NAND latch part, driving part will come NAND. And when we using NAND latch part, you have to connect inverter here to the R. Okay, that we have to remember. This is the logic diagram. The same logic diagram we can do in another way. Just I replaced this not with NAND. Okay, both are right. This one and this one also right. And I did another way. See here, instead of using inverter, here I am getting this. I am connecting here. Okay, whatever this connection I am connecting here, so it will become same. Ultimately, what we getting will see here. Suppose if I apply 0 here, and if it is a positive level 1, 0, 1, if any input is 0, then it will become 1. So here I am applying 0, I am getting 1 inverted. Ultimately, that one only coming here. Na? Okay, so if I apply 0 here, I need 1 here. If I apply 0 here, I will get 1 here. That one I can connect here. Okay, so when I apply 0, here I will get 1. Here I need 1. So that one I am connecting here. So we no need to use inverter in this case. This is also same as above diagrams. Out of these three diagrams, we can use any. Okay, this is the symbolic representation. Okay, now we'll see the characteristic table. We'll take the clock D, Qn, n plus 1 and state. This is positive level. When I apply 0, next state will be as present state. Okay, whatever the D value or present state values. But when I apply 1, circuit responds. Circuit will trigger at a positive level. Okay, so this Q1 can be 0 when we apply input 0, or Q1 can be 1 also for input 0, and Q1 can be 0 for input 1, and Q1 can be 1 also for input 1. Like that we have to write. Okay. Suppose when I applying 0, what it means? When I applying 0, this is 0, it will become 1. It means we are applying S0 or 1. When we apply S0 or 1 in SR gated latch, what happened? Circuit became reset. Na? So 0, 1, here it will become 1, 0. 1, 0 means NAND latch will give reset. Okay. That reset we have to write. See here in these two cases reset 0 will come. When I apply 1 here, what will happen? D value. When I apply 1, it will become 1, 0. It will become 0, 1. When I apply 0, 1, circuit become set. Circuit become set. Set means 1. Okay, so we can simply draw logic diagram and characteristic table from the SR gated latch itself. Okay, for D also. This is the excitation table. This excitation table also we can get from this characteristic table. Okay, I told in previous lectures how to get excitation table from characteristic table. Same process. Okay, here one shortcut, whatever n plus 1, Qn plus 1, that will become D. Blindly we can write for D. Okay, not for other latches or flip-flops. Now in the characteristic table you can observe one thing. You can write n plus 1 also blindly, it will become as d. Okay. For these conditions, four conditions. Okay. And one more thing we have to observe in logic diagram. Whatever d, that will become yes. Straight to the yes we have to write q. If we are using this latch part as an AND. Okay. Finally, we'll see the characteristic equation. I am getting Qn plus 1 equal to D. When I substitute in the K map, that only happening in the excitation table. Na? Ultimately, in the excitation table and characteristic table also same happening. Because ultimately characteristic equation means we have to determine n plus 1. Okay, n plus 1 is nothing but D. Okay. Now we'll see with the positive level D gated NOR latch with the NOR latch part. Okay. Symbol will be same. So here latch part NOR. Whenever this is NOR, I told driving part will be AND. But we have to observe two changes here. Here we have to connect inverter to at R place, not at S place. Whenever this is NOR latch part, this change we have to do. Okay. And straight to the S we have to write Q bar. That also. This is common. This is applicable everywhere, we know. Okay. Right. Now characteristic table will be same as the previous. Excitation table will be same as previous. Characteristic equation also will be same as previous. Now we'll see with NAND negative level. Negative level means you just here you have to connect inverter. In the symbol you have to keep bubble here. Okay. Characteristic table, simply here this clock values we will change. Here previously 0, now it will become 1. Here these all becomes 0. Previously all are 1s. This is only change. Everything same. This is same. This is same. Now with negative level NOR. Okay. Here we keep inverter and here we keep bubble. Okay. Now just this is same as previous and this is same as previous and this is same as previous. Okay. Before watching this lecture, you should do watch SR gated non-gated latches. Then only you can understand this. Okay, right.